To give this talk, I'm going to walk through a series of anecdotes based on my personal experiences, starting off when I was like a young warthog. It's like a Lion King reference, and kind of ending up with where I am now and what we're working on now. And like hopefully through this journey, I can like connect the decisions that I've made, the products that I've built, by a series of themes and lessons that will help you guys. And happy to chat about that later. And then finally, a quick, a little bit of an off-script remark. I was trying to prepare my slides, and I was using ChatGPT for all of these plots. And I was like, ChatGPT, draw me a Pareto frontier. And it drew me this like straight line, it's ugliest straight line. So I was like, great, make it concave. And then it drew it like this. And I was like, concave down. And it drew another line that was like even more slanted facing upwards. So I was like, okay, convex. And then it made me this same line again. So then I was like, ChatGPT, define concave and convex lines. And we had this like long dialogue. And I could have made the plot myself, but I thought this was like a good intro. Okay, so that's where I'm going today. I think we'll take the questions at the end, but I'm also totally fine taking questions live, just like raise your hand, whatever. And I think it will hopefully make this more interesting and more interactive. Sweet. So, acknowledgements. Literally none of the work here except for the first and like least interesting problem I'm going to talk about, I did myself. And so like huge shout out to all the people on this slide, many other people who have actually built and worked on the things I'm going to talk about here. That said, all opinions are my own, not theirs, or especially not the company that I work for. And yeah, let's talk a little bit about me. So this is my older son. I have 2 kids. We're in a restaurant. I am a data scientist at Stripe. I manage a group of teams. It's called Optimizations Engineering, Machine Learning, and Data Science. It's kind of like just crowd everything into the name so that nobody gets offended, was the strategy there. We basically work on optimizing merchant outcomes in Stripe. And so you can think of like a merchant's profit using Stripe, which is a payment processor, as a function of the merchant's costs of using Stripe. In turn, costs that Stripe passes through from the networks and the banks. The fraud that they suffer on their charges, if you're a merchant and you have a fraudulent charge, you actually have to pay a fee plus refund the goods. Talk more about that later. And then the proportion of their charges that actually get authorized, right? Like somebody visits your website. I'm sure you visited a website before and had it follow you for weeks and weeks and weeks. I actually was going to order my team some T-shirts. I visited some T-shirt websites, and now I'm just getting inundated with T-shirt website emails. But you can think about each of these visits as an attempt at conversion, and that's sort of a funnel. So we optimize that funnel, and then we optimize costs, and then we optimize fraud. We jointly optimize these 3 things. Before Stripe, I worked at Twitter for 6.5 years. And at Twitter, mostly I worked on experimentation. Also worked on forecasting in the beginning. Also a huge adopter of Sean's earlier very controversial tool, Profit. Yeah, that's sort of like what I did there. This is my email. Feel free to email me anytime. I love like chatting with people, junior people, senior people, any really direction on that axis. Happy to help with career advice and stuff. And then I also have a LinkedIn. Feel free to add me. Happy to chat there too. I still haven't perfected my LinkedIn feed. It's really terrible. So if anybody has any advice for how to get like interesting content on your LinkedIn feed, please let me know. Okay, cool. So I think that concludes my introduction. And now we're going to talk high level about the things that I'm going to talk about today, the broader theme. So the broader theme here is, as a data scientist, as a manager, whatever I am, I often get brought in to sort of help someone else make or evaluate a decision, right? And so especially on my experimentation platform team, but similarly on my optimization team, the vast bulk of my inbound requests have to do with decision making. The impetus for this slide deck was I was actually brought into some meeting to help somebody come up with a way to evaluate if shipping this thing we were going to build is good or not, right? And they were like, what do we need? What's our sample size? You know, how do we get to like a minimum p-value threshold to tell if this thing is good or not, right? And I gave them the number. I didn't say any hot takes in the meeting, which is kind of my style if you ever have a meeting with me. But in my head, I was thinking this is a very inefficient way to make decisions because we've already built the thing. If we ship it and it's not good, then what, right? It creates all sorts of principal agent problems between the institution and the people who are building the optimization systems to have your job be effectively the decision-making police. And it creates this sort of like garden of forking paths of, oh, we can't ship it. Well, then what do we do to ship it? And that's a very difficult question to also answer if you don't understand the underlying space, the underlying policy space that you're operating in. And so even though I worked on an experimentation platform for 6.5 years, I really don't like talking about p-values, MDEs, variance reduction, peaking, Jesus Christ, or like any of those related things. I do it, I'm happy to do it. I actually own an alert that does some like detection of heterogeneous treatment effects. It sends automated alerts. I was getting pinged about some automated alerts this morning that are definitely all false positives, and I feel like this sort of work is really not worth it unless you have some sort of like underlying strategy that you're trying to optimize, some way of navigating that strategic policy space based on empirical results and theory, and then some sort of end goal for doing this navigation. And I'm going to take you through my entire journey of coming up with this grand, deep philosophy from when I first started thinking about it in 2016 to where I'm at now. So that's the broader picture. So I don't know, defining the terms, this seemed like a good idea at the time when I made the slide because I found this cool picture. And I was like, maybe I'm going to be having this talk and they'll be like, what's a decision, Brent? What's a strategy? So like one nice way to think about a strategy, I'm going to omit the decision thing, but a nice way of thinking about a strategy, and these all, by the way, have analogs in experimentation, machine learning optimization, what have you, is that a strategy sort of has three parts, right? There's a diagnosis, which is a theory describing the nature of the challenge that you are being brought in to solve. There are these guiding policies. So this is sort of like, how can you navigate this space? What are the mechanisms by which you can navigate this space? And then there are the coherent actions, these like set of specific things you can do to navigate the space. In the context of like my current job, this contextual bandit thing I was going to talk about, the space is conversion rate. The guiding policies we have are to like maximize conversion rate within some like set of constraints, right? These constraints with cost and fraud, et cetera, et cetera. And then the coherent actions are things we can do. There's thousands of them that we can do sort of in all sorts of combinations. So then we have many thousands of things we can do in order to achieve this outcome. I'll give you some examples later, but that's how these terms apply to the problems that we're solving. And so you might think, oh, great, like, cool, strategies make sense, decisions make sense, but I disagree with you, Brent. I think strategies are very easy to do, and decisions are very easy to do, and none of this is like a very interesting talk to have, and I think that's an okay point of view to espouse, so I want to argue a little bit more about why talking about strategies is helpful for you. And so, if you go to a decision maker, and this is a nice plot I found on Twitter. If you go to a decision maker and you say, hey, great, so we have this space, you know, we have this optimization function, and within this space, we can deliver you 5 different outcomes. And here are the confidence intervals for all of them. You pick the outcome you want, you know, trading off these 5 metrics. It's very difficult for people to think through strategies by themselves. Even if they can tell you, okay, we're optimizing conversion rate, we can pull these thousands of levers, it's very difficult for non-technical stakeholders, for executives, for people who don't do optimization for a living to determine where the optimal place, or even the set of trade-offs that they can navigate in sort of a Pareto frontier is a priori before they go to you. So it's always worth trying to frame this conversation as a function of diagnosis, policies, and actions before you get brought in to make decisions. Similarly, I also hate shipping criteria. I don't know if does anybody work at a company with shipping criteria here? Sweet, yeah, let's chat. Yeah, it's like the dumbest thing. Like, just like, don't do it if you get asked to do shipping criteria. Be like, what is like yeah, great. We should just give you a couple slides. I hate them. We can chat about that later too. But like shipping criteria is just sort of this like staring into the abyss of why trying to optimize for decisions rather than strategies is the wrong thing to do. All right, so how did I come to this conclusion? Way back in 2016, I joined the experimentation team from the forecasting team. And I was like, sweet, I'm going to do like variance reduction. That's kind of all I knew at that point. I was going to do Cupid or regression or whatever you call it. And they were like, Brent, welcome to the experimentation team. We're going to make images bigger on Twitter. And you need to design and analyze that experiment. And I was like, no, I'm a specialist. Like, this is beneath me. Nevertheless, I designed and analyzed that experiment. And so, like, well, what did we do? We made the images bigger. The images got more engagement. Things that weren't images got less engagement. There was a trade-off. We estimated the trade-off. It was within the shipping criteria that I laboriously established at that time. So we shipped the change. That was it. It was done. And I was like, okay, great. I'm an amazing experimentalist. I'm a great scientist. I've solved this problem. And then guess what? A year later, literally, they were like, Brent, stop working on variance reduction. We have this other important problem to solve. And I was like, sweet, is it bandits? Is it online bandits? I'm ready. And they were like, we need to make the images bigger yet again. And you can actually see that this reached its apotheosis, where at some point they made me test images on the entire screen. Like literally, we couldn't make them any bigger at all. And so having been through this experience twice, I started to think maybe this is a little bit inefficient. So what did I do at that time? I made a line, or I made a couple points. There was this nice paper that I found whenever I was working on this, like 2016, where some people at Pandora did a series of experiments to estimate sensitivity to ad load. And I was like, wow, great. Rather than thinking about this as some set of like discrete decisions that we optimize over the course of years, we can think about sort of mapping the entire dose response curve, or the entire line that exists between the trade-off between engaging with video tweets and engaging with non-video tweets on Twitter. And so what David Riley, I think his name was, did is they like varied the amount of ads and how long they were that you saw on Pandora. And then they plotted the trade-off between how much money Pandora made on the x-axis and how much people used Pandora on the y-axis. As you can imagine, the fewer ads, the more you use it, the more ads, the more money they make. And like not only that, they fit a regression. So like they weren't just limited to their like 6 data points that they generated. They created a generalizable formula to help future policymakers determine if I want to make ad load this much, how much revenue will I lose? So I was like very inspired by this. I did the same thing at Twitter. I once again asked ChatGPT to make me an image of Twitter with video taking up the entire screen. I got this, and I just rolled with it. So like, okay, so applying this framework back to this problem, what is the diagnosis? The diagnosis here, the underlying strategic question is that consumption of videos is good for social media platforms because social media platforms can monetize videos through pre-rolls. So you see these on YouTube if you don't pay for YouTube Premium. You have to sit through like 45 seconds of content before you click, and then you actually get your video. But there's a trade-off, the bigger you make the videos, the smaller everything else is on your screen. And so we can actually estimate, fully specify that entire trade-off. And so what I did was I made a tool that automated the next N versions of this experiment. And I kid you not, there were many, by fitting a regression, testing a dozen points on this space of like how big for the sort of like device and the user we make the video it should be, and then plotting this curve. So you just input the device, and we give you the trade-off at any given level. So that was what I ended up doing. Why is it good? This is from one of your tweets, Sean. It's a good tweet. So why is this good? Well, we saved a lot of time. We saved a lot of like bad experiments. We saved a lot of decision makers' agonizing meetings. Because at least once a year when I was working on this, we thought about the trade-off between video size and revenue and engagement on non-video tweets. And so instead of having that meeting every single year, people could use this tool, fit the regression, rerun the experiments to re-estimate the coefficients, and then draw a line between video size and engagement loss. So this is my first From Decisions to Strategies idea. It's draw a line. So if you're ever asked to bring to work on an experiment and they want you to evaluate a decision, ship a thing, think about if there's a space. It's a discrete space, a continuous space, if there's some sort of space that you're operating within, and rather than just testing the thing that you ship, try to test things that are proximal to the thing that you ship. Distal, is that the right word? I don't know, far from the thing that you ship. And then instead of just testing one thing, test 10 things along some sort of frontier, and then draw the line. And then you can extrapolate by fitting a regression, and this is 2016 tech, we do cooler things now, but still I do this regression thing, by fitting a regression between these points on the line to help people understand the trade-offs, and then they can determine the optimum. You can go to the policymaker and say, great, you want to make videos 25% bigger? I already have the estimate for you. It will reduce engagement by 10%, but increase revenue by 50%. Saves a lot of time, helps the business make more efficient decisions, and it minimizes the regret of people having a ton of sunk costs from a specific idea, right? We're going to make it twice as big. And then having to go away from that specific idea, making it twice as big is not good with no alternative in mind. I'm sure people have been in here before where they had to tell some sort of stakeholder or person who laboriously built a thing that the thing that they built was not good and that you didn't have any specific suggestions for them and it was an awkward meeting. This happens to me a lot. If you have suggestions there, I'd love to hear them. All right, so based on building this line, I got to thinking. By this point, I was the manager of the experimentation team. So not only did I do external requests, I could prioritize my own things. So then I was like, I have this genius idea. And my genius idea was we'd not only done this really wasteful series of video size experiments, but by 2020, when I started to think about this, we'd run more than 10,000 experiments on our platform. And very rarely did somebody go to run the newest video size experiment and look back and find the N most relevant video size experiments for their particular application. And so there was this huge corpus of historical data that was wasted in terms of decision-making, strategy design, and optimization for our business's functions. So we went back and we laboriously scraped all the results that we could and we backfilled them. Here's a scatter plot. This is actually literally a scatter plot from a tool I built. So let's talk about why that was useful. I have another slide here. Here's another scatter point, scatter plot. So I moved from the lines to the scatter plots is the gist of this section. Why is this useful? Because this can sort of systematize the learning from the video exploration experiment from just one specific use case of plotting points and fitting a regression to any specific use cases. And for the Microsoft people in the room, this was very much inspired by your papers on the institutional memory and stuff. And so what we could do is when someone went to design an experiment, regardless if it was video size or if it was, I don't know, ad load or if it was make the heart a star, we would show you all of the most similar experiments and then their effects aligned by whatever outcome of interest you had on the y-axis, and then the causal mechanism, what specifically you were doing on the x-axis. And we collected this data going forward in easier ways, so then we had richer and richer and more robust metadata over time, which I'm not going to talk about too much now, but if you're curious, ask me. And then what did we end up doing with this? Well, whole spaces of Twitter's product development were revolutionized. We learned a lot of really useful and very interesting things. I have some on here as quick examples. A quick example is you probably are on some apps that send you push notifications and emails, right? Great. And those push notifications and emails are annoying, and you annoy them. So you're annoyed by them. So you turn them off if you can on your phone. You block the emails, so on and so forth. But what you might not understand from the platform's perspective is that they have separate email and push notification optimization teams, both trying to take your attention. And so what we learned from looking at scatter plots of past experiments, more or less, is that sending push notifications and sending recommended content emails are substitutes. So if you do better at push notifications, your emails get worse. If you do no push notifications, your emails get way better. And if you withhold both at once, you get a much more true impact estimate of all of your push notification and email recommendation strategy. So this was helpful because it inspired the two teams to work together better on a joint strategy. You can also think of there being complements, where you have two causal mechanisms that work together. A great one in the context of Twitter was sort of like push recommendation selection and content that you see on your feed. I'm sure Facebook does all sorts of optimization on this. If you make the push recommendations better, then the content ranking on the feed gets better because you build this like really nice engagement and training loop for your recommender systems. Cool. So this, next slide, is my second big from decisions to strategy idea that I was going to pitch you guys on, which is not only building a line, but making a scatter plot. So what's a scatter plot? Well, in this particular instance, it's collect and analyze unstructured metadata from relevant prior experiments to your domain before running the experiment for the thing that you're asked to work on. I do this all the time. When we're asked to build a new ML system now, there's almost always been prior attempts. I work at companies with decent amounts of institutional memory, and it's pretty easy to try these sorts of things. Prior attempts to build ML systems in that domain. Can you go back and find the 10 most relevant attempts to build ML systems in your domain and then figure out what were the lessons learned from those attempts? I'll talk about this a little bit later, but I find this to be a very fruitful exercise when I'm brought into a particular application to help someone make a decision, transform it into a strategy. Before you even go and explore the strategic space, look back and see what the past examples of experiments, optimization systems were in your space, and then translate those things into your particular strategy, your particular problem, by making scatter plots. All right, that's idea 2. Before we get to idea 3, I'm going to drink some water. All right, so idea 3, reply guys. All right, so we've gone from the line to the scatter plot. Idea 3 is at some point we wanted to make replies go up on Twitter. So I was like, sweet. Let's uprank tweets that have a high probability of reply. So what we did is we took the weight that tweets with probability of reply was, we multiplied it by 26, and I learned my scatter plot lesson, right? So we did 27, we did 72, we did 2, right? Try a bunch of different weights, see what happens, plot the line. But like, in this particular instance, we didn't have a line. We had an ellipse among the outcomes of interest that we cared about. And not only did we have an ellipse in a 2-dimensional axis, we had an ellipse in sort of like an n-dimensional axis. So you can think about there being all sorts of like valuable interactions people can take with tweets and unvaluable interactions. So you can favorite them, you can retweet them, whatever. You can block them, you can mute them, you can do these negative things too. And it turned out that like naively changing this one particular hyperparameter in our model had these really complicated effects across dozens of other hyperparameters that we had in our objective function. And so we didn't understand our full objective function. And so like eventually you get to this place where you're in a multi-dimensional space and you can't just make blind lines. You can't just make plots, even though those are very helpful for stakeholders especially. You have to optimize across 5 things, right? So how do you plot 5 things? This is the same slide, I go to this one. You really can't. You really can't plot 5 things. But there do exist algorithms, there do exist online bandit techniques that will help you explore this space and then produce you a series of trade-offs, the Pareto frontier, the multidimensional Pareto frontier that you have between the particular outcomes of interest. And so what we learned through this experiment is not only the shape of this frontier, but a few different very interesting interactions between the hyperparameters that we put into our optimization function and then the outcomes that came out of it from exploring this frontier. Let me give you a quick example. Let me see if I have it here. Oh, no, I don't have it here. Shoot. Let me give you a quick example while we're here. What we learned is that if you increase the weight for the sort of like probability of reply hyperparameter a lot, holding all of the other weights constant, what you would end up seeing is more reports. Things that people are very likely to reply to, but very unlikely to engage with positively by like liking or whatever, you'll start to show at that level of focus. And then what you will see, and what I was trying to show here with my three-dimensional Pareto frontier, is that the things that are most likely to be replied to when you dramatically upweight replies, the x-axis is like the weight on replies versus favorites, y-axis is favorites, is content that's really likely to be reported. And so like not only do you have to think very carefully about your entire optimization function, the weights between your hyperparameters and their outcomes, but you should do the best that you can to plot and explore this entire space, this entire Pareto frontier between all of the different outcomes of interest in your model. I also find it very helpful to plot them individually in pairs, right? You look at the replies, you look at the reports. You do all the pairwise combinations you can of all of the individual constituent parts of your objective functions, because I don't know about you guys, but at least I have never worked in a space where we have a univariate objective function, right? Like just like optimize profit. Well, profit has like all these components. It has costs, it has revenue, it has like the actual cost of your intervention. And so I find this to be really helpful. So what is the third big insight? Well, so now you've gone from like, you make the line. Second insight, you make the scatter plot. Third insight, right, is you write down your objective function, and then you map out a Pareto frontier among all of the different trade-offs that are hyperparameters and outcomes within your objective function. And this will give you a sense for the trade-offs underlying your attempts to optimize the strategic space. And I do this all the time. Whenever we have to optimize something new, I try to plot all of the different pairwise ellipses between outcomes. Cool, okay, so that's a lot of stuff. I'm getting to my final example, and I'm like almost out of time. So this is really perfect. This is timed this well. So yeah, so my final example is what I work on now, profit maximization for Stripe. We have a bunch of different cool projects and products. Happy to chat about that later. And this is actually a image from a Stripe blog post. And what I'm about to teach you is that each business effectively has its own unique optimal point in the trade-off between cost, fraud, and profit. And that, sorry, cost, fraud, and conversion. And that point is determined by a few things. First, the margin that they make on that specific transaction. Second, the amount of fees that they will pay if that transaction is fraudulent. And then third, their costs of goods sold. And like, it's very difficult. Like, does anyone here work at a business? Cool. This is like a test to see if you're paying attention. Does anyone here know the specific margin that they make on any given thing their business sells at a different price point? Just, you do. You do? What do you sell?
Antiviruses.
Really? What's your margin? Is that okay? Give me a hypothetical.
45.
45%? Good, wow, that's high. Cool, so this guy is great and we should work together and you'll be very helpful. I'm like down to work with you on some Stripe stuff. Most businesses don't know this. And worse, it's heterogeneous. It's different for different products. Like if you buy something on Amazon or Wayfair, the margin that Amazon or Wayfair will make off of your purchase is very, 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 very complicated and very, very, very unique to your specific purchase. And so, bringing it back to this point, your tolerance for fraud is lower the lower your margin is. Because at some point, your margin will go negative. I see people thinking this is great. So like the idea here is you sell something, you make $2 off of that thing. If on expectation, the cost you will pay from fraud for that thing is greater than $2, you just sold something that loses you money. So every business has different optimal operating points at the sort of like conversion fraud frontier. It's a really nice blog post by this guy who still works at Stripe, used to work at Stripe, that outlines why this is the case and discusses the trade-offs. Happy to share it with you. So we wrote this, we built a model to do this for everybody, right? To help them do this, and it's part of our Radar product. You should use it. Happy to chat about that. And pick the optimal point on this curve for them where they can maximize the operating profit of their business. So wow, look, ML. Check it out, guys. So like how does this model work? How does this work? Well, we effectively have a multitask mixture of experts model that predicts a bunch of different things individually. The fraud for the thing, for the specific attempt, the probability that it will be converted, some things related to costs, and then we all bundle it all together and we calibrate the output because otherwise it's very difficult to interpret across each of these things to determine which intervention works best for which specific type of fraud. I give some examples here, and I'm happy to chat about this later. And then, oh yeah, sweet, here's a system diagram for our model that I stole. Yeah, so we can determine this for each particular merchant. Happy to chat about that. And then we can use an online contextual bandit to explore between hundreds of different best possible outcomes and pick the best outcome for the individual merchant, individual charge. And so if your margins are 45%, right, you might be more aggressive. Like fraud is less of a big deal for you than someone who literally has a 1% margin. Like if you have a 1% margin and the thing is fraud, you're screwed. Sorry, a little bit of an exaggeration, but it's not great. Yeah, great. So fun things to discuss. This was another failed attempt for me to get something useful out of ChatGPT. I swear to God, I use it every day. I'm like very good at it, but when I was trying to make these slides, I just totally whiffed. I don't know what my prompt was here. Yeah, so like some fun things to discuss. I'm running low on time. Are model architecture choices? Why do we end up with multitask mixture of experts? How can you like add new levers and then explore more quickly when you have a contextual bandit? This is like a really hard problem for us because like we have already tens of thousands of levers. If we add one new thing, then it's very difficult to quickly gather data on the effectiveness of that one new thing and when we should use it. And yeah, those are my things. And so yeah, this is my like final slide, and this is from, I think, a really good Pinterest blog post on mixture of experts, which I highly recommend. And so yeah, so my final recommendation when you're going from sort of like decisions to strategy is design an entire engineering system to explore your multidimensional space, to find an optimum. And yeah, hooray, you have won, you are the strategy now. And so that is my talk.